All right, folks, so here we will take a look at 5.3. We'll graph the rational functions that we sort of started hinting at graphing in section 5.2. Now, when we're working in here, we're going to be relying on some skills that we have been practicing and already relied on so far. Number one, we're going to rely on our grade 10 factoring. And if you take this skill any further, which you should be able to do later on in this chapter, then we will be relying on our grade 12 factoring that we learned in section 3.6. Okay, next in here we're going to rely on this. We're really relying on the skills that we learned in section 5.2. Oops, 5.2. So if you're feeling a little bit uncomfortable with that, in particular, the skills checking for horizontal asymptotes, then I want you to go review that from the video. And let me see, lastly, we're relying on what we learned in section 4.3, which was using a sketch or a number line to determine the positiveness or negativeness, if you will, of a function. Okay, so we're going to sort of jump right in here. We'll follow a specific procedure that, again, we already hinted at yesterday in section 5.2. So we'll begin, we always check, if we're going to graph a polynomial function, the first thing we do is we check for holes. It's a trap if we don't do that. If we accidentally check for vertical asymptotes first, we might find a vertical asymptote where there actually isn't one. So we always need to check for holes first. We do that by factoring the numerator, factoring the denominator, and checking to see if there are any common factors. Next, we check for vertical asymptotes. Okay, so that's the roots of the denominator. Luckily, we've already factored our denominator, so it should be pretty straightforward. We just find those roots. Next, we're checking for the roots of the function itself, right? So this time we're looking at the roots of the numerator. And this sort of makes sense. If we think about how a fraction works, if our fraction is a over b, right? A is my numerator, b is my denominator. Well, if I set a equal to 0, if this is 0 over b, then my entire fraction will just equal 0. Okay, well then it stands to reason that if my numerator equals 0, my entire function will equal 0. Okay, well let's try something else. What if b equals 0? Then I have a over 0. Well, if I put that into my calculator, or I might know it, we're not allowed to divide by 0. And the reason is this gives us an undefined solution. Okay, so if our solution is undefined, that's where we get a discontinuity. That's where we have an infinite discontinuity if there's a vertical asymptote. Now, algebraically speaking, every once in a while we can have both occurring at the same time, right? If a equals 0 and b equals 0, then we have 0 over 0. This is also a discontinuity. This is undefined, right? So it's a discontinuity. Now, when this happens, usually, not always, and we will learn in the future when it's not, but usually it's a hole there. Okay, that's what's happening when you have a factor in your numerator and a factor in your denominator, both the same at the root of that factor. Okay, so that's just a little bit aside. Yes, this all makes sense algebraically. After we've checked for holes and vertical asymptotes and roots, then we can go on ahead and check for our horizontal asymptotes. I'm not going to write out the entire spiel there, but we know that we're comparing the degree of our numerator to the degree of the denominator, just like we learned in section 5.2. And lastly, we're going to check for the positive and negative intervals of our final function. We'll do that by looking to see when my numerator is positive and negative and when my denominator is positive or negative, and putting those together. So we can do that through sketching or through working with a number line. Okay, so first we'll look. We have here a function f at x equals 3x plus 12 and x plus 4. The very first step that we work with here, as always, we check for holes. Okay, that means I need to factor my numerator and factor my denominator. That should be nice and easy. That means f at x equals, I can common factor out 3 here, x plus 4 divided by x plus 4. And what do you know? I do have a common factor. And we can write with short form here. Common factor of x plus 4. So we would say there's a hole at, and this is going to be at where x plus 4 equals 0, right? The root of x plus 4, the root of this common factor, and that is at x equals -4. So now I know, okay, there's going to be a hole at x equals -4. Are there any other common factors? No, there are not. But what I can do here, and let's just move this over here so there's a hole here. And I'll keep working down. Okay, so now that I've checked for holes, I'll check for any vertical asymptotes. And in fact, what I'm going to do is I'm going to simplify my equation. So now I'm working with 3, and I can cancel these out, and I just need to make sure I write x cannot equal -4. So now I know that my function, this is mathematically, this is showing just as much as it did above. I know that my function f at x equals 3. Where x cannot equal -4. Well, I know how to sketch f at x equals 3. I don't need to check for vertical asymptotes or roots or horizontal asymptotes or even check a positive or negative interval. I know how to sketch f at x equals 3. That's extremely straightforward, right? F at x equals 3, that's a horizontal line, or y equals 3. I'm looking at something just like this, except at x equals -4, where there is a hole. So I would write here, there's a hole. That's at -4. This is what my final function looks like. Okay, not that difficult right now. We don't notice we only actually followed up here. We only followed one of the 5 steps because it was more straightforward of a problem. Now let's go down and try maybe a little more complicated one. And again, we'll begin checking for holes. Okay, so now we're working with -2 over x minus 4. We can say right away, okay, this is clearly already factored. My numerator is already factored. My denominator is already factored. It's already factored. And there are no common factors. So we can say definitively there are no holes. Okay. If there are no holes, then we can move on ahead. The next step is to check for vertical asymptotes. So let's see here. Vertical asymptotes, what we're doing is we're checking the roots of our denominator. Okay, well my denominator, x minus 4, is a factor. And maybe I'll write VA so that you know that I'm looking for vertical asymptotes. X minus 4 is a factor, so I can set that equal to 0 to find the root. So x equals +4. So this is going to be, therefore, there's a vertical asymptote at x equals 4. Okay, so I can sketch that in right away. All right, so I find x equals 4, that's right here. And there's a vertical asymptote, nice and easy. And when I sketch it in, I always sketch it in with a dashed line, and I always label it with the equation of the line, not an inequality, with the equation of the line. Okay, and then I can move on forward, and I can look to see what's next. Okay, any roots? Oops. Any roots? Okay, so I'm going to check and I'm going to find any roots of my denominator. I can see here of my numerator. I can see here my numerator is 2. There's no variable in my numerator, so there are no roots. Okay, and then I can again keep pushing forward. I've checked for roots. Now it's time to check for horizontal asymptotes. This is from section 5.2. That here I can see I'm comparing the degree of my numerator to the degree of my denominator. So write horizontal asymptotes. That's what I'm looking for. The degree of my numerator is less than the degree of my denominator. Therefore, I have a horizontal asymptote. Yes, we can use shorthand as we go through these. That's fine. Therefore, I have a horizontal asymptote at y equals 0. Okay, well, if I have a horizontal asymptote at y equals 0, I can sketch that in, right? Again, the dashed line. Again, the labeling. Y equals 0. Fantastic. So now I've checked for holes, I've checked for vertical asymptotes, I've checked for roots, and I've checked for horizontal asymptotes. Now that I have my two asymptotes in here, I'm just going to give you some options that we can be looking at here. Okay, so the possibilities that we're working with, if we have these asymptotes here, I can approach this asymptote, my horizontal asymptote down here, I can approach this from above or from below as x approaches negative infinity. So my function might be above, my function might be below. Okay, it's one of those two bright green lines. Next, as I approach my vertical asymptote, my function can approach a vertical asymptote as y approaches positive infinity or negative infinity. Okay, now I don't have any roots here in the middle, so I know my function's not going to cross the axis, but it would be possible in the future, sometimes, it could be possible to have my function approaching negative infinity here from below, and then positive infinity here, so it could cross my my asymptote there, and I know you learned about that in section 5.2, where we can cross over an asymptote. Right, but here what we're focused on is that my function is either approaching, as it approaches my vertical asymptote, x equals 4, as it approaches that from the left, that's all I'm doing here, from the left, then my function will either approach positive infinity if it goes up, or negative infinity if it goes down. Okay, we'll keep going. On with the vertical asymptote, we need to look as our function approaches it from the left, and our function as it approaches it from the right. So my function can either be, again, approaching positive infinity or negative infinity as it approaches my vertical asymptote from the right. And lastly, and I'm hoping you've caught on already to why I'm using so many colors here. Lastly, I'm not sure if yellow will show up, we'll go with brown. Lastly, my horizontal asymptote as x approaches positive infinity, my function can approach it from above or from below. All right, so with each color, I've sketched in two different options. Only one of those two options will be what we're looking for. All right, and we'll see that as it comes into fruition. Now let's take a quick look. We're going to need two more colors. I apologize for so many, and I'm hoping you can follow what we're doing. I think it will be pretty straightforward. Now, if we are looking for the positive or negative intervals, right? Positive or negative intervals. Then we can either sketch each function, the numerator and denominator, or we can make a number line. Here we're going to work with our numerator, and we'll sketch our numerator and denominator. Okay, so we'll sketch here my numerator, and it's kind of hidden in there, but my numerator isn't just 2. My numerator is negative 2. Okay, so we'll take that negative on. So that means that my numerator, we'll call my numerator f at x equals negative 2. All right, numerator f at x equals negative 2. So I can sketch that in right here. And I'm actually going to label it, just so I don't lose track of it. I'll label it with a numerator. I'll just write numerator. Okay, and then we'll take a look, and we want to sketch as well our denominator. Well, sketching our denominator should be pretty straightforward as well. So my denominator, and here we'll call it h of x. I'm choosing these letters because g of x is our rational function here. So h of x here equals x minus 4. I know how to sketch that. That's a linear function. Its slope is x, and its y-intercept is negative 4. Fantastic. So I'm working with, let me see here, 1, 2, oops, I need that line. About there. Okay, so that is my denominator. And for each part of this function that we're worried about, we can compare the positiveness and the negativeness. The positivity, we're comparing if our functions, if my numerator and my denominator are both positive or what, for each section. Okay, so for the light green parts, as my function approaches negative infinity, then my numerator is negative. My numerator is negative. My denominator is also negative. So a negative divided by a negative, right? So right here, I'm looking at the x values right in here, right, where the light green is. And I'm looking to see the location. Sorry, I'm looking to see the y values of my numerator and denominator. My numerator is clearly below the x-axis. My denominator as well, clearly below the x-axis. So it's a negative divided by a negative. That means that I'm working with a positive part of my rational function. So I'm not working with the bottom part. I'm working with the top part. Okay, next, into the red part of my function. Again, I'm looking at that portion. I'm looking at this part of my domain, and I'm looking at the numerator and denominator to check to see if they're positive or negative here. Well, nice and straightforward. Let's go with the red pen again. Nice and straightforward. Here I have a denominator that is below the x-axis. So it's a negative divided by a numerator that is still below the x-axis. My numerator will always be below the x-axis in this case because my numerator is a straight line. So it's a negative divided by a negative. Again, it's a positive. So that means the red portion that I'm working with here is above the x-axis. Okay, so you can see here how I'm piecing together my function because I'm choosing at each point of my function, for each interval, I'm choosing the part that I want to work with, the part that I can work with. Okay, so next, now I'm working with the light blue. I'm going to work over here, and this is the portion of the function that I'm looking at, and I'm looking to see, okay, is my denominator positive or negative? Well, my denominator, that's gray, it has now crossed the x-axis. Now it's positive. It's above the x-axis. So my denominator here is a positive divided by my numerator, which is still negative, so divided by a negative. That means I'm working with a negative, because any positive number divided by a negative will be a negative. That means I'm working with a negative part of my function here. So that means I can remove this upper light blue part. It means I have to be working down here. It means my function was approaching that vertical axis, that vertical asymptote. As it approached from the right, then my function is approaching negative infinity. Okay, and I can we'll write that down in a future example. And lastly, with our brown here, we're looking to see, is my function above or below the x-axis? Nice and straightforward. My denominator is positive here, right? It's above the x-axis. My numerator is still negative. That means I'm working with the negative part, so not this upper part, but rather I'm working down here. So when I get ready to handle my sketch, then really I can start and I can just try and visualize, okay, what's going to happen. Now, you will notice this has a lot of similarities to our number line, right? If we had been working with a number line here, we would need to choose, okay, what kind of intervals do we need? Because it's not just the roots. We're used to just choosing roots, and we would say, okay, this function has no roots, so I don't really need to put anything on my number line. The whole function's either positive or negative. But that's not true, because a function can cross the x-axis. It can go from positive to negative or negative to positive if there's a root or if there's a vertical asymptote, right? We did not have any of these with our polynomial functions, but we have them with rational functions. So we need to write out on our number line, we need to write out any vertical asymptotes or any roots. Well, we could do that pretty easily. In this case, there is only one vertical asymptote, so we could test right here. We could test a value less than -4 in the interval from negative infinity to, it's positive 4 to positive 4, and then test another one from positive 4 to positive infinity, and we know that there's a vertical asymptote here from our work up above, right? So it would be pretty straightforward. You should be able to handle that. Now, I will give you, I went into so much detail here. Honestly, I think I might leave the third one for you to try on your own. I will be very stingy. I will upload this solution right away so you have it available for you. The difference is, you know what, I won't even give you that. I will say, there's one more piece I wanted to give you. Right, around a vertical asymptote, just if we try and describe what's going on. Around this vertical asymptote, I can say, okay, and we're used to writing our end behaviors using this notation. This time we're going to describe the behaviors at an asymptote, right? So we have a vertical asymptote, and if you're feeling overwhelmed already by what I just went through, then I want you to go practice example 3. I want you to try it out on your own, compare it to the video, or compare it to the solutions, and then come back to this part of the video. Okay, so we can analyze this vertical asymptote, and we can say, okay, as x approaches my vertical asymptote, which is in this case 4, and I'll say here from the left, right? So we've practiced this notation before. As x approaches 4 from the left, y, what does y do? Okay, so as x approaches 4 from the left, I'm looking from here, I'm getting closer and closer and closer to 4. My y values absolutely skyrocket there, right? My y value approaches positive infinity. So we would say here y approaches infinity. And then we would say, okay, as x approaches 4 from the right, y approaches, and I go up here and I check and I approach 4 from the right, and I can see that my y values plummet. They get very low very fast, and that is y is approaching negative infinity. Okay, so just a little aside. Now we have, we can use that, how we've practiced our end behaviors so far, we can use that same notation to describe a function's behavior around a vertical asymptote. Okay, so folks, try out example 3 on your own. Like I said, the solution will be posted. I know this may have gone into a lot of detail. You may find this a little overwhelming. That's probably going to be, if you do, you're going to find it overwhelming because you struggled a little bit with 5.2. Otherwise, you may have found it very straightforward, in which case, awesome, keep moving forward, and we'll get on to 5.4 next.